Okay, 4.3, solving polynomial inequalities. So consider a quadratic equation of this form. Okay, so if we had f at x equals x squared minus 5x plus 4. Okay, if we solve this by factoring, we would do 0 equals x squared minus 5x plus 4. And we would look for two numbers that multiplied to 4 and add to negative 5. Okay, so we would get the roots, negative 4 and negative 1. So x minus 4 would be one factor, x minus 1 would be another factor, and then, the actual roots would be x equals 4 and x equals 1. Okay, so that's just factoring from grade 10, quadratic. Okay, so this graph here clearly shows the quadratic, and it shows where the two roots are. Okay, so 1 and 4. So what we're going to be doing today is we're going to be actually graphing, and not a true graph, just a sketch of a graph of polynomial functions, and deciding when the polynomial function is equal to, greater than, or less than. Okay, so if we're taking a look at this graph, these x-intercepts actually, and then there's just the dotted line. These are not asymptotes. This is just so that our eyes go to these sections and divide it into section 1, section 2, and then section 3. Okay, so if we're thinking about when does f at x, when is it equal to 0, we're thinking about specifically these roots. This is when the values of x intersect the x-axis. Okay, if we're thinking about when f at x is greater than 0, what we're thinking about are any values above the x-axis. Okay, so above the x-axis. In this case, it would be from negative infinity to 1, and then it would be from 4 to infinity. Okay, and if we are thinking about f at x when it's less than, so less than, of course, when we're taking a look at the x-axis here, it's below the x-axis. So in this case, from 1 to 4. Okay, any polynomial inequality can be solved graphically. The roots of the equation will determine the intervals where its solution will be found. Okay, so use the graph below to state when f at x is greater than 0, less than 0, and equal 0. So we can go ahead and put that on our paper. So when is f at x greater than 0? And we can say on. We don't need a comma. Okay, f at x is less than 0 on, and f at x equals 0 on. And I'm putting on just to preface this so that we can put some intervals in here. Okay, I do like doing the equal 0 first. I think it's good to identify where the x-intercepts are and then kind of divide those with our eyes. So we have an x-intercept at negative 3. So let's put at x equals negative 3, x equals negative 1. Okay, so that's going to be another section. And then x equals 2. Okay, so next one. When's f at x greater than 0? Okay, so we can see, actually, let's reference the x-axis. Anything above that is going to be greater than 0. So this interval here, so it's going to be negative infinity to negative 3. And that's why it's good to always locate the x-intercepts first. And then also this interval here, so negative 1 to 2. So we can say and negative 1 to 2. And now when's f at x less than 0? So again, reference this x-axis and take a look below the x-axis. So negative 3 to negative 1, and 2 to infinity. Okay, example 2. Solve x squared minus x minus 6 is less than 0. Okay, so here are the steps. First, we want to determine the roots in numerical order. Okay, how we do that is factoring. So this is a trinomial. It's obviously a quadratic. What two numbers multiply to -6 and add to -1? Okay, factors of 6 are 1 and 6, 2 and 3. This is the one that always gets me. So which one adds to -1 is going to be 2 minus 3. So our function factors to x plus 2, x minus 3. So when is this less than 0? We can go ahead and branch these off. We're going to get x equals -2 for the x-intercept and x equals 3 for the other x-intercept. Okay, so we're done number 1. Now, number 2, create a chart to organize your intervals. Okay, so just on the side of my paper, I'm just going to show you what this looks like, okay? If we were to graph -2 on our graph and 3 on our graph, the intervals are going to be -infinity to -2, -2 to 3, and 3 to infinity. So I always like to do that on the side because usually I graph it anyways, or the question asks to graph it. It's a lot more clear. And then what we do is we take these 4 numbers here, 1, 2, 3, 4, okay? And we put them in a chart. So I'm going to put -infinity, -2, 3, and infinity. So what we're essentially doing is, just like the intro, we're dividing this just with our eyes, and we're trying to decide if the graph exists or is defined above the x-axis or below the x-axis, and where it's defined for each. Okay? So what we're going to do is we're going to test numbers between -infinity and -2. If it's a positive number, we're going to draw the graph like this. And if it's a negative number, we're going to draw the graph like this. Okay, we're going to do the same thing between -2 and 3. If it's a positive number, we're going to draw our graph above the x-axis, negative number below the x-axis, okay, and so on. So this is the first time that we're going to be seeing this style of chart, but this is not going to go away. This is going to come back in rational functions, and it's going to come back in calculus as well. Okay, so instead of actually taking these numbers and plugging them into this long expanded equation, what we're going to do is we're going to take each of these factors and list them down the side. So we have x plus 2 and x minus 3. Okay, so we're going to choose a number between -infinity and -2. I'm not going to go too big, but let's go -5. So we don't actually care what the numbers are because, again, it's not a graph, it's a sketch. So if I were to plug -5 into x plus 2, am I going to get a positive number or a negative number? Well, I'm going to get a negative number. And if I plug in -5 to x minus 3, I'm also going to get a negative number. Okay, 2 negative signs will yield a positive. So we know that this is going to be above the x-axis between -infinity to -2. Okay, now let's pick a number between -2 and 3. 0 is always a nice number because if we would plug 0 into 0 plus 2, we're just taking the sign of the plus 2. So that's positive And 0 minus 3 is going to yield a negative. A positive and negative always gives us a negative. So in this interval between -2 and 3, it's going to be below the x-axis. Okay, and now let's choose a number between 3 and infinity. I don't know, let's choose 10. Okay, 10 plus 2 is going to be a positive number. 10 minus 3, also a positive number. Positive, positive yields a positive. Okay, so this is now our graph. Okay, so there's one of two ways. So there's two ways of presenting the solution. So we have f at x is less than 0 on. So we can go straight to the chart and we can say, okay, well, it's negative here. So that's the interval -2 to 3. Okay, or we could have went over to the graph, and if you like the visual, as long as your visual is accurate, we can also see obviously -2 to 3. And that's the solution set. So example 3, given f at x equals -x, x minus 4 squared, we're going to solve for when f at x is greater than 0 and when f at x is less than 0. And then we're going to sketch the curve. Okay, so step 1 was to find the zeros. So I'm just going to rewrite f at x equals -x, x minus 4 squared. If we want to find the x-intercepts, we want to sub in y equals 0, or f at x equals 0, better math form. So we have 0 equals -x, x minus 4 squared. Okay, then we're going to branch these off. So we have a monomial. We have -x equals 0. Even if we divided both sides by -1, we're still going to get x equals 0. Then we have x minus 4. We can put equals 0. Okay, so x equals 4. Have in the back of your head that this is squared because that is going to come up and it is going to change our answer. Okay, so far in my head, I'm thinking to myself, okay, we have x equals 0 and then x equals 4. Okay, now let's do the actual chart. So again, like this x-axis can act as a number line. So this is infinity and this is negative infinity. And if you actually like visualize this, we can think of our intervals this way. So we have negative infinity to 0, 0 to 4, and 4 to infinity. Okay, we can get rid of that. Okay, down the side, I'm going to point out two things going on here, okay? So we have -x as one factor. You can either do this as a -1 and an x, but you have to consider everything from the original equation. So we can leave it as -x, that's fine. Then we have x minus 4 squared. Okay, think about this. X minus 4 squared. What is anything squared? What is going to be the sign of anything squared? Okay, so anything squared is going to be positive. We don't even have to test these numbers. We go all the way across and we say, okay, positive. It doesn't matter what's in this bracket, it's squared. So now all we're really doing is testing the numbers in -x. So negative infinity to 0, let me choose -1. Do this darker, -1. Okay, we know if we're going to have negative of -1, all we're doing is negating. okay, negate. That just means flip the sign. So if we subbed in -1 there, we'd get +1. Okay, choose a number between 0 and 4. I don't know, let's just choose +1. That's a nice small number. +1 subbed into -x, we're going to get negative. Then choose a number between 4 and infinity. Let's choose 5. Sub 5 in, -5, we get a negative number. Okay, so positive yields a positive. Okay, so between -infinity and 0, we're going to be above the x-axis. And then negative positive yields a negative. So between 0 and 4, we're below the x-axis. Then negative positive yields a negative. So between 4 and infinity, again, below the x-axis. So this here was from the part of the function where it's x minus 4 squared. We can see order 2, we can see that it bounces off. So no longer like the last question we have alternating positive negatives. This time we have a positive, negative, negative, and that's okay. So if we want to write out our solution set, we would have f at x is greater than 0 on, and then we have to write out f at x is less than 0 on. So f at x is greater than 0 on, it's positive here, so -infinity to 0. Okay, we can also see that on the graph right here. And f at x is less than 0 on, okay, two different intervals, 0 to 4 and 4 to infinity. Okay, 0 to 4 and 4 to infinity. Okay, and on the graph, we can see that 0 to 4, 4 to infinity. Okay, here's my warning. A lot of you might be inclined to say, oh, well, that's just 0 to infinity. But it's not, because in this inequality, we don't have an underline, right? We don't want f at x is less than or equal to 0. In that case, we would include the 4 because 4 is at 0. We would also include the 0 because 0 is at 0 as well. However, this doesn't have that underline in the inequality. It doesn't have the equals to factor, so we have to take the 4 out. So 0 to 4 and 4 to infinity. It's not 0 to infinity. Okay, example 4. So example 4, given f at x equals x cubed minus 5x squared plus 2x plus 8, we're going to solve for when this function is greater than 0 and when this function is less than 0, and then we're going to sketch. Okay, so for a function like this, because it's not presented in factored form and this is presented in expanded form, we have to actually fully factor it. So let's list the possible factors. The leading coefficient is 1, so we don't have to do anything about that. We just list the factors of 8. So plus minus 1, 2, 4, and 8. Okay, I always assess the coefficients first. So 1 minus 5 plus 2 plus 8. So it's not going to be f at 1. Let's try f at -1. Okay, that's going to give us -1 minus 5 minus 2 plus 8. That is going to give us 0. So -1 is going to be one of the roots. And we're going to do synthetic division. So we're going to use the coefficients here. 1, -5, 2, and 8. Okay, bring down the 1. We get -1 times 1 is -1. Let's add these. We get -6. -1 times -6 is 6. Add these, we get 8. -1 times 8 is -8. Add these, and we get 0. Okay, so now we're left with x squared minus 6x plus 8. This is now just a quadratic. So what we're going to do is we're going to find two numbers that multiply to 8 and add to -6. So the factors of 8 are 1 times 8, 2 times 4. Okay, 2 and 4 add to 6. So we are going to make both of those negative, so they add to -6. So x minus 2, x minus 4. And then we get the solutions x equals 2 and the solution x equals 4. Okay, we don't have to rewrite this with all three factors. Remember, the three factors would be x minus 2, x minus 4, and then x plus 1. But we don't have to do that. What we're going to focus on is the chart, and I'm going to go ahead and graph these three x-intercepts. So -1, 2, and 4. And then I'm going to use -infinity and infinity so that we have this number line. And this number line is going to correspond with the tops of the chart. So -infinity to -1 is going to be one interval. -1 to 2 is going to be another interval. 2 to 4 is going to be another interval. 4 to infinity is going to be another interval. I'm going to get rid of that. Okay. And I totally lied. Let's rewrite this so that we can take into account all of the components in our chart here. So our components are going to be x plus 1, x minus 2, x minus 4. Okay, so x plus 1, x minus 2, x minus 4. Okay, so choose a number in this interval between -infinity and -1. Let's just choose -2. If we subbed in -2 to -2 plus 1, we're going to get a negative number. -2 minus 2, negative number. -2 minus anything, negative number. So I want to go over this. A negative and a negative yields a positive. Now a positive and a negative yields a negative. Okay, let's choose a number between -1 and 2. 0, best number ever. Okay, 0 plus 1, we're literally going to just take whatever number or whatever sign that is in the middle. That's the sign that we take. So 0 plus 1, 0 minus 2, and at 0 minus 4. Okay, so these two negative signs yield a positive, and a positive positive yields a positive. Okay, so just starting this graph, we're going to be under the x-axis between -infinity and -1, over the x-axis between -1 and 2. Now, let's test a number between 2 and 4. Well, let's test 3. 3 plus anything is going to yield a positive number. 3 minus 2 is still positive. 3 minus 4 is negative. These are all positive, that's fine. And then we have one negative, so this is negative overall. So that's going to be below the x-axis. Now let's test one more number between 4 and infinity. You can even do a big number, you can do 10. Just so that you know that that positive 10 may outweigh some of these negatives. So positive 10 plus anything is going to yield a positive. 10 minus a smaller number than 10 is still a positive. And 10 minus 4, right, a smaller number than 10, still a positive. We get positive, that goes up. Okay, so f at x is greater than 0 on, okay, we can either look on our graph here or in our intervals here. So -1 to 2, and 4 to infinity. Okay, and f at x is less than 0 on, okay, we can either look at the graph, so negative infinity to negative 1, or we look here, negative infinity to negative 1, and less than 0, 2 to 4.